So here's the motor apart, and I was right. That's what happened. So this magnet plate is supposed to have 8 magnets on it, and 4 of them have come off. So I've cleaned this surface up, and I'm going to prep it for re-gluing them. I almost wish all of them would have popped off so I could re-glue them all, but I remember when I glued them last time, I only glued a couple of them. I think 2 on this plate and 1 on the other. Now all the ones on the other plate, these ones are all still tight. But this one, for some reason, I think what happened is one of them, here's what might have happened, and again, maybe this is me, but these bolts that hold these magnet plates to the inside of the case, so they hold it into these holes here, into here, into these slots, which I'll talk about in a second. But when one of them was stripped, and I took it out, and actually the bolt thread was worn out, so I just got a new bolt for it, had to cut it down, and I'm sure I cut it the exact same length as the bolt that was in it. But if it was even just a hair long, it would have come through here and it may have popped the magnet off of this plate. If it happened while it was spinning, then it may have taken the other ones out. I don't know. Maybe just bad luck. Who knows? So I got to find out a way to glue these magnets to these plates. And here's the thing: this gets powerfully dangerous. These magnets. Pulling this plate off, I had to make a little puller assembly to get the plate off, to get this magnet off. It was here, and I pushed against the center shaft and pulled this plate off, and it was a lot of work. This is dangerous kind of magnetism. If you got your fingers pinched in here, if you drop this with your fingers in here, it would really hurt. So I'm trying to be careful. I got this rubber pad down so that, you know, these things aren't sticking to my steel bench. I'm trying to separate all the pieces, keep all the magnets as far apart as possible, because once they stick together, they're a pain in the ass to get apart again. So I got to find a way to glue those back onto here. But I thought while I had this motor apart, I would kind of go through the makeup of it. This motor is a little bit different than most. Most electric motors, you have a rotating electromagnet in the middle, and then, you know, either permanent magnets or electromagnets on the outside of it. This is a little bit different. I'm not sure what this is. This might be called a pancake motor. I've heard of a thing called a pancake motor, but I never really, I mean, if anything, this looks like it would be called a pancake motor. I mean, it's very, most armatures are long and round. This is much thinner. This is not exactly an Etek motor. An Etek motor is a motor that was made by Briggs & Stratton. I think they still make them, or they make maybe it's called Mars now or something. There's a kind of an offshoot from that. But this was an imitation or a knockoff of a Etek motor several years ago. I've been finding some information. This is called a Manta motor. And apparently what this was designed for is actually as a generator. I read a blog the other day that said that they made a whole bunch of these things. They were going to use them as generators in wind farms and stuff. And then they had a whole bunch left over and they got sold as electric motors. So I ended up buying one off of eBay, I believe, several years ago. So I kind of want to go through and figure out, there's some things I would like to know about this motor. And while I'm doing that, I'm going to show you guys how it works. So, as you may or may not know, electric motors they derive their motion, the rotating motion, from interaction between 2 magnets. Either one electromagnet and a permanent magnet, or 2 electromagnets. You can't do it with 2 permanent magnets because you have to be able to switch one, you have to be able to change the polarity of one of them. So if we have permanent magnets, and we do, this one has this whole plate full of permanent magnets, and you'll see I have it marked off red and yellow, and there's a reasons for that, and we'll go through that in a second, but there's one of each of these plates on either side of this rotor. So this would flip over, and I don't want to get it close because if it gets in there, it'll get stuck. So this sits on top of this motor, and you notice there's 8 magnets on here, right? So I've divided this rotor, or the armature, up into 8 sections. So 1, 2, 3, 4, 5, 8 sections. And then the thing to round the whole thing out, oh, and so there's a plate on either side. There's one of these on either side of this pancake. Then this is the set of brushes that is on this motor. This brush set sits right here on the end of this armature. And what it does is, if you look down in here, one of the terminals is hooked to the inside ring, and the other terminal is hooked to the outside ring. And if you follow the wires through from this ring, you'll find out that it'll be positive, negative, positive, negative, positive, negative, positive, negative. So every second one is on the positive ring, and every second one's on the negative ring. So when you put power to both of these, what ends up happening is you end up having a circuit between the positive up through one of the brushes, through the rotor, or the armature rather, and back down the other one to the other brush. So by putting a current through something, we create a magnetic field. So when this is down on top, what you end up with is 8 magnetic fields being built up in this ring, reacting with the 8 magnetic fields of these magnets. So I'm not sure how they do north and south with this, whether one is upside down. I don't know how you'd tell north and south. Maybe when I put them together, I put them together wrong, because they'll stick. Oh, see, that way doesn't stick. Yeah, I'm not sure how to decide whether it goes this way or this way. And this magnet seems to have lost a lot of its. I hope I haven't damaged it. See, that one's. I hope I haven't damaged the. These magnets haven't become damaged. They don't seem very strong right now. But I know this thing's really difficult to pull off of this thing. They'll be what they'll be. I have to try putting it back together. Another thing this motor does is it grunts when it accelerates. It has a sound. I'm not sure if it's a speed controller or this motor. So I don't know whether it's these magnets are losing their strength or whatever it is. So here's the question I have. So if you look, this ring is held on with the 4 bolts into this housing. And it sits in here, and those 4 bolts line up with slots on the outside. So you can turn this ring, right? You can turn this ring in relation to the housing. So you can change the magnetic timing of this motor. So I'm trying to figure out where it should be, whether it should be in the middle, whether it should be one way or the other way. This motor primarily spins one direction, so my guess is you can bias the magnetic field for the direction you're spinning it. And my guess is when you have it timing advanced, so that the magnets, and this is guessing, so if I have this magnet plate here, and I energize the, so that we're going to call yellow north, and if I energize this quadrant of, or this 1/8 of the armature, it will attract to this one. Then as it gets here, the brushes grab the next one and make it, and they turn it to negative, and it gets pulled to the south. So by changing the timing, if this field is pulling this area right here, then if I move the plate back again, this angle is more vertical to that area. If I turn the plate a little bit this way, my guess is it does this, and pulling from a different direction. One thing I'm not sure of on this motor, and I would love somebody to be able to tell me, if you look at this motor, it's kind of odd that, so here's the quadrant, here's the magnetic field would build up in here is my guess, but if you look, they have these so in between the magnetic fields, or in between these windings is a piece of metal that comes out, and it goes ahead like another, I don't know, more than a 1/16 of a turn. If this is an 1/8, this one goes from here to here, and so this piece is connected to here. I don't know whether it puts a magnetic field out here for kind of giving it some forward timing. I don't know what this is for. If anybody has a guess, I'd love to hear it, because this is kind of the oddest motor I've ever had apart. So my guess is by turning the relationship between, you're not changing the relationship between the brushes and the rotor, but you're changing the relationship between the magnets and I'm sorry, the armature. So what you're doing is turning it this way and changing the pull angle of the magnetic field is my guess. Like, so here, maybe this might be better for speed. It pulls more into the center, but you wouldn't have as much torque. And maybe this way you have more torque, but doesn't run as well at speed. I did find one thing on the internet about what this adjustment is for, and somebody said, well, you just adjust it until you have the least amount of current draw. And maybe that's so you can use it bidirectionally. I read another forum that says these brushes, the way they're angled here, they don't like going counterclockwise. And sure enough, I'm using this motor counterclockwise. So, and I guess that's because as it turns, it heads into, so this would, actually no, this would seem like it would be right, because as this turns for me, so this is turning, no, this is turning this way for me. So the sides of the brushes, these terminals are hitting the sides of the brushes. If it was spinning the other way, it makes no difference. It makes no difference. These brushes, if you look in there, get some light, these brushes are, in a sense, doing this. And everything between the yellow and red right there would be, say, north. And everything between the red and yellow would be south. And then the magnet plate, which, again, upside down, but sits on here, right? This now allows that magnet to interact. And by turning the magnet plate, you change where it interacts with the brushes and where it's creating a magnetic field in the armature. So I've tried different adjustments on this. I've tried having it forward, I've tried having it back, I've tried having it in the middle. It doesn't seem to make much difference. Anyway, so I'm going to see if I can find some proper adhesive to glue these magnets onto this plate. You know, I can just, you know, measure the space here and space them out properly, find something to glue them on, and then we're going to try this motor again. And if it doesn't work, I'm going to have to see if I can find a replacement for it. The new version of this is much wider. It doesn't matter, I have lots of room on the vehicle, but it's not cheap. So I'm really hoping, I'm going to try this one more time, I'm really hoping I can get this up and running. So here's our motor apart. Here's all the pieces. So here's the magnet plate that is damaged. All these magnets are just right now on with magnets, like the magnet is sticking to it. All of these magnets can be removed and moved around. Over here are the brushes. So these brushes sit upside down on top of this armature, and they rub around this. They rub around this circuit, this section right here. So this is where the brushes touch. So if you put this on top, you end up having a brush every 1/8 of a turn. So there'll be a brush here and a brush. So between, actually, at each yellow and red line will be a brush section. So, and then here is the other brush or magnet plate. So this one over here, this one was not damaged. So this one actually is bolted back into the housing. So this is the one end of the motor, and I've got the magnet plate bolted into that. And this sits down over top of the, I don't want it to get too close because it'll get stuck on there. Hold on. This part goes down over top of here, but the magnets are going to attract to it, so I can't get it too close or it's going to pinch my fingers in there. So here's a problem I'm having. Well, first of all, did you know such thing as magnet glue? So this is actually a product built or made for putting magnets on steel. This bottle was like $38, $50 with taxes and delivery. So it's cheaper than buying a new motor, but you know, of course, Loctite, right? Loctite makes adhesives for everything. And this is actually magnet glue. So here's the problem I'm having. As I was putting this together, as I was cleaning this all up and getting it ready to glue these magnets on, I wondered whether these magnets had a north pole and a south pole on here. So what I did, when I had one of these magnets off, I put it over top of this plate to find out whether any of them attracted and repelled. And it turns out the yellow ones, they were the ones I had marked yellow, were repelling the magnet, and the ones that were red was attracting the magnet. So I know that there's north-south, or whatever. Let's call it north-south, north-south. So I made this one the same way, and I timed it so that, see on the back of here, they have these four bolts. These bolts are bolting this plate on. So the ones that line up with the bolts, so in this case, the yellow ones that line up with the bolts, that's what I did is I got another magnet, right? So that magnet attracts to the yellow. All four of these magnets all attract to the yellow, okay? And they repel to the red. And I can feel that when I put this over top. So I made this one the same way. I found the bolt holes on the back, and I put the ones on top. And what did we say? We said that the yellow ones attract. So I made this one so that the yellow ones, oh, I have this backwards again. Every time I seem to do this, it seems to change. Anyway, so that one's attracting, that one's repelling. Maybe it depends on which magnet I'm using on here. But attracting and repelling. So, okay, it's perfect. I have them both the same. Because in my mind, if a company's going to manufacture this, wouldn't you make sure both of these are the same for ease of manufacturing? There's no identifying marks on them. Nowhere does it say this is a left or a right or a north or a south. So my guess is they would make them both the same. And by doing that, you'd have one set of magnets on either side of the armature. You'd have you'd have a magnet plate here and a magnet plate here, right? And so when the brushes touched here, it would make a section of this into a magnetic pole, and it would have the same magnets on both sides that would pull it through. That makes perfect sense to me. But just before I went to kind of finalize it, I thought, you know what? Let's make sure that this section of the housing, so this is the main section of the housing, and let me just move it over here. So these two sections of housing need to go together. And they line up with a key right here. So these things have to line up. But if you look in here, this bolt here doesn't line up with the slot on the other side. They're 45 degrees out from each other. If you hold it like that, here's the slot on the one piece, here's the slot on the other. So they're 45 degrees out. Now I'm confused. Do I assemble these two magnet rings 45 degrees out from each other? Because in my mind, you want the same magnet pole on each side so that if this is south, it's pulling toward north magnets. If you have a north magnet on one side and a south magnet on the other, it doesn't seem to make sense to me why you would want to do that. So before I get my fancy glue and glue this together, I need to know, because I can't change this by 45 degrees. There's only 4 bolts on the back. If there were another set of bolt holes here, if it wasn't right, I could just turn it 45 degrees. But I can't. And it's a lot of work to do that. It's a pain in the butt taking this motor apart. So there's not much information online about these motors. I think I'm going to stop for a minute. I got to think about this because I want to do this once, and because if this glue works, these things aren't going to come off again. So I need to know whether they should be the same, because it makes sense to me from a manufacturing point of view. If you drop 2 of these on the ground, how would you know which one's top and bottom or left and right? Because they look exactly the same. So in my mind, you'd make them the same, but then these two housings don't line up the same. They're out by 45 degrees. So I don't know. I'm going to think about it for a day. I think it has something like when this, here's another thing, this is keyed to here. These bolt holes go a certain way. So this, these bolt holes line up like that, so that these brushes come out of a specific spot. So if these two, if the circuit, and notice that the brushes, between these brushes, a magnet. So if there's a north-south here, and this is, if this creates a north, and this is south, it's going to attract, and if it's south and south, it's going to repel. I don't know. I'm not sure. I'm going to have to put more thought into this. I think what I might do is put this up on its bottom like this and set this in and try powering it and see if I can put a piece of paper over top and see what the magnetic field looks like. Or maybe I'll try, because I think with one set of magnets and this sitting on top and the magnet holding it down, it'll stop, the bearing will stop against the bottom, so it'll only go in this far and stop. But I don't want to do it yet, because once it's in there, it's really hard to get out. So I'm going to give this some thought. Sometimes it's not good to know a little bit, you know. I know enough to think that the magnetic fields have to be across from each other on this thing. Oh, but on a regular armature motor, North is on see, this is not a regular armature motor. This motor is different. On a regular armature type motor, there's north on one side, south on the other, and maybe top and bottom if there's four stators or magnetic fields, right? So this seems to make sense that this one of these quadrants would be one magnetic pole, and it would react with the magnetic pole between this. I don't know. I'm going to go online and see if I can find anything. Somehow I doubt it. This is kind of a weird little motor. But we'll see what we can do. Man, you gotta love the internet. So I went looking for some information on this thing, and it turns out what it's called is an axial air gap motor. So most motors, traditional motors, are radial air gap. The air gap is on the outside of the armature, and between that and the magnets. This one, the gap between the magnets is axial, sideways. So I found out, and of course, here's where I found the information. Good old Wikipedia. They talk about this. This originally was called a Lynch motor. It was invented by a guy named somebody Lynch. And this motor is interesting in the fact that it is, well, let me show you. This thing explained exactly. This picture explains exactly how this thing works. And then I'll show you. I'll explain to you why I have how this gave me the answer. So if we put the brushes on top of here, right? Put the brushes on and see where one of these brushes comes out. So if the brush is touching this one, for example, right? It's going to come out. It's going to come out here. It's going to, so the current is going to come in. Say it's positive. It's going to come in here, out between these, create a magnetic induction in this iron core, right? So now it turns these into magnets. It comes out and it follows this curve out to here, out to this one, and then this crimp. And if you follow that through, the crimp goes backwards the other way and connects to this one and comes back in again. And this, where it comes in, is 45 degrees out from this side. So it creates one magnetic field here, and then it comes from a brush out this way, across through here, and 45 degrees this way, and looks for the other magnet, the same pole magnet. So it's got two magnetic fields. It's a little hard to explain, but the Wikipedia page actually says that these magnets are 45 degrees out from each other, and because the housings are 45 degrees from each other, this one lines up with this hump, and on this side it doesn't, right? So these are out 45. That means these magnet plates need to be the same. So over the holes needs to either repel or attract, depending on how I'm checking. So that makes it easy. Now I can get this it takes 24 hours for this glue to set up. So I'm going to get these things glued tonight, and hopefully I can put this motor together, a couple days from now. But thank you, Wikipedia. Thank you, Mr. Lynch, for supplying this picture of how it works. And now I can put this motor together. Man, you gotta love the internet. Okay, I think we're ready to kind of go back together again. So here's what I've done. Right, so I re-glued these magnets in. This one was cracked already, and I have the piece for it. And I thought about gluing it on, but I think the problem with that might be that this now being broken is going to create a different pole, like a north and south pole, and it's going to create, I think, some bad magnetic flux probably between this piece and that one. I think it's probably better to have a weaker, smaller magnet than to have two different poles there by having this broken edge. So it'll be a little bit weaker. Another one of these is actually lost a bunch of its strength. When you touch a screwdriver to it, it has much less, everything's magnetized here, hold it. It has much less stick to it, but for the most part, they're all about the same. So this is the magnet. I bolted it into the housing, and you can see that these four bolts are holding that on, and they're in slots. So I can tweak the position of that magnet. But I'm going to start with this one in the middle, And I've already assembled the other end, and I'm going to start with that in the middle as well. So I'm starting with them, I can tweak it back a bit maybe, but I'm starting with them in the same place. I read it on a forum or something someplace that the reason you can adjust those is to change the timing of the magnets to get, it's either for biasing the direction you're going to use it, or to kind of trade off speed and torque to each other. I'm going to start it in the middle. What I would like to do is at some point bring in or get my oscilloscope hooked up and measure the current of this thing as it's accelerating and do these adjustments. One of the problems with that right now is these has been apart so many times in its life, the threads in here aren't the strongest. The more I take it apart and adjust things, the more worn out they're going to be. I think this motor's in probably a much better condition than it was before. So I'm just going to put it in the middle and use it the way it is. This will be low on the list of kind of tweaking this to see what I can do. I'm expecting this is going to run well enough that I don't have to mess with this. At least, fingers crossed, that's what I'm hoping. So, another interesting thing about this motor is there's nothing holding these two halves together. There's one bolt that keeps them keyed. This little tab down here lines up with this. But there's nothing holding it together. The magnets hold this motor together. It does fit down over top. Let me just get the snap ring off. I hope it goes together because when I took it apart, it seemed like there was too much space between this part and this part. I'm sorry, not enough space. It was rubbing. So it had a washer here before, and I got one that was like 20 thou thicker. And I put this washer in, so now there's more space in here. I'm hoping that, it didn't seem to rub, but I think it's just best not giving it the opportunity to rub. The problem now is this going to fit on? Is this going to go down far enough? There are a couple of really tiny shims in here, but this thing was all shimmed up, from brand new. So I'm going to set this back down over top. And again, this is where fingers get pinched. So I'm going to try to line up as best I can. Right, so you can feel already that the magnets are holding it together. I'm just going to, I had something here I could tap it down with. I'm just going to lightly. Sorry about the noise. Perfect. And it looks like there's just enough room for the snap ring, and then the pinch bolt will pull this together, and I have a motor. I'm going to get it all fastened together properly before I try to turn it, just in case anything's rubbing right now. But fingers crossed, this is a motor that doesn't have to come apart again. If you're watching this video because you've been following my project, then I apologize for going on about this motor. But if you're watching this video because you have one of these motors apart, or if you have one that you want to work on and you're wondering how it works, then there's a bunch of things I'm learning as it goes back together. So bear with me while I try to share some of my frustrations here. So right now we have the rotor section in the front housing, right? And the snap ring is done up. Everything's good to go. It will rock back and forth. You can feel the magnet grabbing it, which to me kind of makes sense. It's hard for me to tell how much space is in there between the rotor and the magnets. But, it's not rubbing. It actually looks maybe a bit big. So what sets that is behind this snap ring. If you pull this housing off, there are some bearings back in there. I'm sorry, some shims back in there. And I left the same shims that were in it. I thought it was spaced the right way. But now the problem is when I put the back on, I had a washer in here before, and it seemed to be too thin. It seemed to allow, because what this washer does is it sits up against inside this housing, and it, to me, would put some sort of thrust on that bearing to help position so that the rotor couldn't go too close to the magnet at this side. I think this probably helps set the position of the magnet, the rotor, up and down here. So I had a 80 thou in there, and it seemed to have too much play. So I took it out and I put 110 thou in, and it was now too tight. This housing wouldn't go down all the way onto its mating surface. So I took the washer I had and I ground the edges off. It's difficult to kind of find a way to do this accurately, but I just took it and I tapered the edge back a little bit, and I put it in this way. So this tapered edge sits up against this small edge inside here. And now the motor is tight to turn. You can feel it rubbing. So I'm thinking it's rubbing, it's being pushed too far, rubbing on the other side. If I don't know if the spacing of this is only set by the snap ring and the shims on the other side, and maybe I should leave this out. It seems to me to make sense to have it in there, but I think I'm going to put it back this way, so that I'm pushing on the inside on the untapered part, and so it's back to being basically a regular washer. And I think I need to have it help hold this down. Mind you, there's no other bolts in this housing anywhere. Right? The only thing that holds this thing together is the magnetic force. But then why won't this center properly? I guess I have to take it apart at the other side and adjust those shims, but it sure, I mean, it turns okay now. Again, the magnets have it tight. But why does it change when I put this on? When I pull this magnet up into this magnet plate up into this housing with these 4 bolts, when I pull it up, it should pull away from this thing, but it doesn't seem to. Maybe I'm gonna, at least I can get this off without dealing with magnets. This is just, you know, I have to kind of tap the center shaft to get it out, wobble it a little bit to get it out. But it does come out without, you know, I can just leave the magnet plate in there and undo the bolts. But every time I undo these bolts, they get more and more worn out, so I want to do as little as possible. Maybe I'll go on the internet and see if I can see a picture of other ones and see if they have a shim in the back here, or whether you can just see the whole bearing. Yeah, maybe that's a good idea. I'll go see if I can find some images of this and see if I can figure that out. This is the best it's ever spun in a long time. So the motor's back together again. It spins really well. This is the best it's ever spun in a long time. You know, you can spin it by hand and it spins okay. You can hear a little bit of noise when it rubs, but I think it's probably just dust and stuff in there. I don't think it's actually rubbing. The trick was to shimming this snap ring and these small shims in behind it. They were on the other side of the bearing. I brought them out, put them on this side of the bearing, and then what that did is it pulled the rotor forward a little bit, and then on the back, under this cover, with the back bearing was on the shaft. I didn't like the shim that was in it. From me modifying that shim was no good, so I turned another shim, got another washer. I found it was very close to the right size, turned it, put it all together, and it spins great. So I'm going to connect it back to the battery again. I want to see how it sounds. It's always sounded a little bit chunky. You know, it always sounded a little bit gruff. So I want to try it again. Okay, and it's quite a torquer, and I'm not doing the speed control. I'm just turning it on with a set of booster cables on 12 volts. So here goes nothing. That sounds great. I think it's going to be fine. It looks like it vibrates just a tiny bit, but I'm not too concerned about that. And it coasts to a stop. Last time it kind of ground itself to a stop, or it stopped very quickly. So this is the best this motor's been. It's going back on. Maybe not tonight. It's dark now, but put it on in the morning. And I hope I have this motor problem solved.